This is the video for solving for the products of a double replacement reaction. So again, I'm going to give you the reactants. You have to tell me what the products are going to be based on these steps. Step 1, switch the anion. The anions are always the back ends. So you switch the back ends. Check solubility rules, which are on page 6 of your reference table. You must have at least one solid. Without a solid being formed, it's simply going to be a no reaction. So there has to be at least one solid or your answer is no reaction. The final step, which is the final step for every single one of them, is to crisscross those charges. So for example, you first need to look at page 6 of your reference table and you should see this. These are called your solubility rules. Soluble means that it's being able to dissolve in water. So soluble means it is dissolved in water. So that is also known as aqueous. So this is AQ. And if you've not gotten your reference table out, you need to pause the video and get it out now. So soluble means dissolved in water, which means that substance is going to be aqueous. Insoluble means it's not dissolved, which therefore means it stays or becomes a solid. And your key is your products. Okay, products. At least one product must be a solid. So once you switch the back ends, you're going to check to make sure you have one solid, and then you cross charges. So number 1, step 1, switch the back ends. So when we switch the back ends, this means Cl is now going to be with Ag, NO3 is now going to be with Ca. They're both getting new partners. That's why it's called double replacement. So Ca and NO3. I'm bringing this 3 over because it's a part of nitrate. Okay, any subscripts that are a part of that specific polyatomic comes with it. Then plus Ag Cl. Now I'm not bringing this 2 over because it's not a part of a polyatomic and you do not bring over subscripts. Okay, step 1, done. Step 2, we now check the solubility rules and make sure that we have at least one solid. Now, real quick, I do want to talk a little bit more about the solubility rules because you have this one little word that can make a huge difference, and that's the word except. So everywhere you see the word except, you need to highlight, underline, circle, whatever the word except. So here, except, except, except. Over here, and that's it. So the word except means it does not include those. So this means in this bullet, all chlorides, bromides, and iodides are soluble except when bonded with, okay, the word except means when bonded with silver, lead, or mercury. If it is an exception, it is the opposite column. So if it ever ends up where you have a chlorine with one of these 3, it's no longer soluble, it is insoluble. So the word except, anything after the word except, means it's going to be the opposite column. And when you check the solubility rules, you always look at the anion. Okay, so you're always looking at the anion when checking the solubility rules. So for CaNO3, which one is our anion? NO3. So NO3 is nitrate. So you need to find on the solubility rules where it talks about nitrates. And for this one, it is right there. in the soluble column. So as far as we know, this is going to be aqueous, but you need to make sure there's no exceptions. So all nitrates, acetates, ammonium, and group 1. There are no exceptions, so therefore we're going to label this as AQ. So far we have a no reaction because we must have at least one solid. So AgCl. Which one is the anion? Cl, which is chlorine, which we're going to look for chlorides. So where on this does it talk about chlorides? Right there. So now what happens is I'm going to have half of you that are going to go ahead and put that as aqueous and move on from there. But you will be wrong. That's why you have to read just a little bit further. So according to these solubility rules, all chlorides, bromides, and iodides are soluble except when bonded with silver, lead, and mercury. So chlorine in this case is bonded with silver. Silver being one of the exceptions. So since silver is one of the exceptions, that means this is a solid. So then with step 2, you must have at least one solid. Do we have that one solid that we need? Yes. So then we do step 3. Step 3 is simply crisscross your charges. And in this case, we need to crisscross the charges in this compound and in this compound. So for this one, Ca has a charge of 2, NO3 has a charge of 1. So when you crisscross charges, you have Ca, NO3, 2. For this one, silver's 1, chlorine's 1. Crisscross charges, they're both 1. So your final answer is Ca, NO3, 2 plus AgCl. Let's try another one. Okay. AlNO3, 3 plus H2SO4. Step 1. Switch the back end. Switch those anions. So this means I'm going to end up with AlSO4. Why are we bringing that 4 over? Because it's a part of a polyatomic. Plus HNO3. Step 1, done. Step 2. One of these must be a solid. So this means we're going to look at the back end. In this case, what is that? What is SO4? Is it sulfite? Is it sulfate? Is it sulfide? Remember, in order to be sulfide, it would simply just be a S. So it's not just an S, so that means it's either sulfite or sulfate. So SO4 means that it is sulfate. So you need to see where it talks about sulfate. Here, under the soluble column. But again, you must check for those exceptions. Is sulfate bonded with calcium, strontium, barium, mercury, lead-2, or silver? No, that means this is aqueous. Next one, NO3 is nitrate. So you need to find where it talks about nitrates. There. And in this first bullet, there are no exceptions. So that means all nitrates are soluble, which means this one is also aqueous. So in step 2, you figure out whether they're aqueous or solid, and you must have at least one solid. Do we have that one solid? No. That means you need to cross it out and write no reaction. Okay, this is the hardest of the ones that we're done. There's only one slight little thing to it, and we've done it before, so it's nothing new. It's just taking what we learned just now and bringing an old topic back. So first step, switch. So NO3 is going to switch with S. So we get PBS plus KNO3. Okay. Step 2. Check to make sure we have one solid. So PBS, S here is sulfide. So find where it talks about sulfides. And that is going to be right there. So right now, it's insoluble. Check the exceptions. Group 1, meaning is PB in group 1 of the periodic table? No. Is it in group 2? No. Is it ammonium? No. That means this is a solid. So we have our solid. So technically we could move on because we know that this is a reaction. But just to give you some practice, KNO3, nitrate, it's right here. All nitrates are aqueous. So we know that this reaction occurs. So step 2, done. Step 3, cross charges. We have one slight problem. PB. Do we know the charge of PB by looking at the periodic table? No. So this means we have an issue. This means you need to go back to the original compound that it's in and find the charge of lead. Because whatever the charge is of lead over here, it's going to be the same charge of lead on the right side. So in order, if you have a metal that's between 3 and the staircase and you're predicting the products, you must go back to its original compound and find its charge, just like we did with the Roman numeral. So for this one, we need to find the charge of lead. 1x plus 2, because there's 2 nitrates, times the charge of NO3, which is negative 1. All of this equals 0. So x minus 2 equals 0, x equals 2. So since lead has a charge of 2 in this compound, that means over here, lead also has a charge of 2. Sulfur has a charge of 2 as well. When we crisscross, they're both 2s, so they end up canceling. K has a charge of 1, NO3 has a charge of 1, so they also end up canceling. Final answer. The fourth one, you need to pause the video and try this one on your own. When you're done, restart the video and check your answer. If you have any questions about what has been done for this example, please make sure you bring them to class so we can address them. Now we will be doing tons of practice on this when we get back to class.